Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today, we're examining 15 groundbreaking papers from September 17, 2025, all emerging from computational linguistics. These papers reveal how smaller AI models are dramatically outperforming their massive counterparts, revolutionary advances in multilingual AI systems, and new approaches to bias detection and uncertainty quantification. We'll also discover breakthrough developments in cross-cultural content moderation that are reshaping how we think about global AI deployment. Picture this. Somewhere in a research lab right now, an AI system is reading a medical report in Arabic instantly, translating a sign language conversation in real time, and simultaneously fact-checking claims across 17 different languages. All of this is happening faster than you can blink, with accuracy that rivals human experts. This isn't science fiction. This is the reality emerging from computational linguistics research in September 2025. These capabilities represent a fundamental shift in how machines can process and understand human communication across cultural and linguistic boundaries. This field of computational linguistics represents one day's worth of innovation, yet collectively paints a picture of where natural language processing and artificial intelligence are heading at breakneck speed. What we'll discover today might surprise you. We'll explore how translation-based approaches are revolutionizing cross-cultural content moderation, and how researchers are teaching machines to understand not just what we say, but how confident they should be about their own responses. We'll also uncover why some of our most advanced AI systems still struggle with something as basic as pronouns, and how this limitation reveals fundamental challenges in machine understanding that affect virtually every application of language AI. Think of computational linguistics as the ultimate bridge-building project. On one side, you have the rich, nuanced, culturally embedded world of human language, with all its ambiguities, idioms, and implicit meanings. On the other side, you have the precise, logical, mathematically driven world of computers. Computational linguistics is the engineering marvel that spans this gap, creating systems that can meaningfully connect these two worlds. This field sits at the fascinating intersection of computer science, linguistics, and artificial intelligence, focusing on how machines can understand, generate, and manipulate natural language. From the early days of rule-based systems that could barely parse simple sentences, we've evolved to sophisticated neural networks that can engage in nuanced conversations, write poetry, and even assist in scientific research. What makes this field particularly compelling is its dual nature, deeply technical, yet inherently human-centered. The first major research habitat focuses on multilingual and cross-cultural language processing. Here, researchers are working to ensure that AI systems can serve the entire world's population, not just English speakers. This isn't simply about translation. It's about understanding cultural contexts, handling languages with completely different grammatical structures, and ensuring that AI benefits reach every corner of the globe. The Apparatus Model Suite exemplifies this effort, providing state-of-the-art language models trained on over 1,800 languages while maintaining strict ethical standards. These models represent a fundamental shift from English-centric AI toward truly global language understanding systems that respect linguistic diversity and cultural nuance. The second major habitat focuses on bias detection and ethical AI development. As language models become more powerful and widely deployed, researchers are grappling with how these systems can perpetuate or amplify social inequalities. This work goes beyond simply identifying biases to developing systematic approaches for mitigation, while maintaining performance. Think of this as the quality control department of the AI world, ensuring that our most powerful tools don't inadvertently harm the communities they're meant to serve. Researchers are developing frameworks that can prevent AI systems from amplifying social inequalities, creating systematic approaches for bias mitigation, maintaining performance while ensuring fairness, and protecting the very communities AI is designed to help. This represents a crucial shift beyond identification towards actionable solutions that make AI more equitable. Our third research habitat centers on advanced evaluation and uncertainty quantification. Traditional metrics for assessing AI performance often fall short of capturing real-world effectiveness. Researchers are developing more nuanced approaches that can assess not just whether an AI system gives the right answer, but how confident it should be in that answer, and when it should admit uncertainty. This involves teaching AI systems when to admit uncertainty to prevent errors, developing nuanced approaches that go beyond simple right or wrong answers, and creating methods that are critical for high-stakes applications in medical diagnosis and financial advice. The goal is creating AI systems that are honest about their limitations rather than providing confident but potentially incorrect responses. Now, let me share some discoveries that are reshaping how we think about AI and language. The first groundbreaking finding comes from cross-lingual toxicity detection research, where translate then classify approaches consistently outperform direct multilingual models in over 80% of tested language pairs. Second, researchers studying coference resolution uncovered that AI faces an impossible choice with ambiguous pronouns. Models can either resolve pronouns confidently or detect ambiguity, but not both simultaneously. Third, traditional confidence measurements systematically underestimate uncertainty, leading to the development of more accurate confidence assessment methods. Fourth, political discourse analysis using large language models revealed surprising stability patterns in parliamentary attitudes. Finally, processed supervised learning approaches improved conversational AI performance by 6% on complex reasoning tasks, suggesting new pathways for training more effective dialogue systems. Today's paper of the day completely overturns assumptions about model size and performance. Monica Sikoyan and her colleagues at NVIDIA have created the Canary speech recognition system that challenges everything we thought we knew about this relationship. Their work, titled Canary Multilingual Audio-Text Foundation Models, presents models that achieve superior performance while being dramatically more efficient than larger counterparts. The system provides multilingual speech recognition across 25 languages, operates 10 times faster than Whisper, with better accuracy, and was trained on 1.7 million hours of audio data. Most surprisingly, they made the counterintuitive decision to include non-speech audio during training, which most researchers would consider contamination, but actually helps reduce hallucination problems. Their architecture combines a fast conformer encoder with a transformer decoder, representing a careful balance between performance and efficiency. The technical innovation behind Canary represents how smart design beats brute force. Their approach involved a two-stage training process, with dynamic data balancing across their massive dataset. The inclusion of non-speech audio reduces hallucination problems where speech recognition systems generate text even when no meaningful speech is present. They discovered that while alternative architectures like NGPT scale well with massive datasets, Fast Conformer excels after fine-tuning, suggesting that architectural choice should be matched to available data and computational resources. The results were remarkable. Canary-1B-V2 outperforms Whisper Large V3 on English speech recognition, while being 10 times faster. This isn't just an incremental improvement, it's a paradigm shift demonstrating how thoughtful design can dramatically outperform the bigger is better approach that has dominated recent AI development. The implications of this breakthrough extend far beyond specific performance metrics. First, this work provides a clear counterexample to the prevailing assumption that larger models are always superior. In an era where AI development costs are skyrocketing and energy consumption is becoming a major concern, showing that smaller, smarter models can outperform massive counterparts is profoundly important. Second, the research reveals the critical importance of data composition over data quantity, challenging the common practice of simply aggregating as much data as possible. The practical implications are enormous. Speech recognition systems are deployed in countless applications from voice assistants to accessibility tools. Making these systems 10 times more efficient while improving accuracy could democratize access to advanced speech technology, particularly in resource-constrained environments or applications requiring real-time processing on everyday devices. Looking toward the horizon, these advances point toward a future that's both exciting and transformative. The multilingual revolution suggests a future where language barriers become increasingly irrelevant, with AI systems that can seamlessly switch between languages mid-conversation while understanding cultural context and nuance. The advances in bias detection point toward AI systems that are not just more capable, but more fair and inclusive, actively working to counteract historical biases and promote diverse perspectives. Developments in uncertainty quantification suggest AI systems that are more honest about their limitations, saying, "I'm not certain about this. Let me find more reliable sources," rather than confidently stating incorrect information. Perhaps most excitingly, advances in reasoning and tool use point toward AI partners that can engage in genuine collaboration, helping researchers discover new scientific insights, assisting teachers in developing personalized curricula, or working alongside doctors to provide better patient care. Today's journey through the computational linguistics landscape of September 2025 reveals a field in remarkable transition. We've seen how smaller, smarter models are outperforming their massive counterparts, how translation-based approaches are revolutionizing multilingual AI, and how researchers are making AI systems more honest about their uncertainty. The 15 papers we've explored represent just one day's worth of innovation, yet they collectively demonstrate the incredible pace of progress in making machines better partners in human communication. From the efficiency breakthroughs of the Canary system to the ethical advances of the Apertus models, from bias detection innovations to uncertainty quantification improvements, we're witnessing the emergence of AI systems that are not just more powerful, but more reliable, more inclusive, and more aligned with human values. These advances matter because language is fundamental to human experience, and every improvement has the potential to break down barriers and democratize access to information. This presentation was created through AI synthesis using Claude's Sonnet 4 model for content analysis and organization. Text-to-speech synthesis was powered by Deepgram technology to convert the written content into natural-sounding narration. Image generation utilized OpenAI systems to create visual elements supporting the technical content. The synthesized content underwent human expert review to ensure accuracy and clarity of the complex computational linguistics concepts presented. While every effort was made to maintain technical accuracy, some oversights may exist in this AI-generated synthesis. All original research papers and references are provided through the archive preprint server for verification and deeper exploration of the underlying research. Thank you for joining us on AI Frontiers today. I encourage you to dive deeper into these papers yourself. Many are freely available on the archive preprint server and represent some of the most innovative thinking in AI today. Subscribe to the AI Frontiers channel to explore cutting-edge AI research daily. Share your thoughts about these developments on social media and discuss them with colleagues. Consider how these advances might impact your own work or interests and help shape the future of human-AI collaboration. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive preprint server.